I'm a honey badger, and I don't give a shh, beep. On our first day of class, it was foreshadowed that this was going to be a very interesting semester. We would have free time to get to know each other as the experiments ran. In the following weeks, while we waited for our gels to run, our group discussions wandered from topic to topic, but they always seemed to include food and the world's oldest profession. Sometime after spring break, our science balls dropped, and we all turned into honey badgers. And we don't give a shh, beep. This class has taught us so much. It has given us confidence to read and follow directions. We know what those words mean, so we don't make mistakes. Ultimately, we can create a gel and run it. For my final presentation, I chose ELIZA. Not this ELIZA, and definitely not this ELIZA, but this ELIZA, enzyme-linked immunosorbent assay. The ELIZA technology has only been around since 1971, when Eva Engvall and Peter Perlman, two Swedish scientists, discovered it as a way to effectively test for the presence of proteins, nucleic acids, polysaccharides, hormones, or viruses. The ELIZA test uses components of the immune system and chemicals to detect immune responses in the body. The ELIZA test involves an enzyme, an antigen, an antibody, and a substrate. Before the development of the ELIZA, the only option for conducting an immunoassay was radioimmunoassay, a technique using radioactively labeled antigens or antibodies. In radioimmunoassay, the radioactivity provides a signal which indicates whether a specific antigen or antibody is present in the sample. A direct ELIZA is a screening for HCG, the pregnancy test. An indirect ELIZA would be a screening for AIDS or the rubella virus. Both involve a colorimetric change. The ELIZA process is much like working with conjunctions. Conjunctions connect parts of sentences. And just like in the ELIZA, something has to be there to make the connections so the train can get longer. An antibody is placed into an empty microtiter plate where it is absorbed into the walls. Through a process of addition and washing away unbound material, a result will appear. The primary plasma antibodies bind to the specific antigens. The secondary antibodies bind specifically to the primary antibodies. Then, enzyme horseradish peroxidase is added, and this oxidation causes a color change in the substrate, allowing the technician to interpret the assay. ELIZA tests are generally relatively accurate. They are considered highly sensitive and specific, and compare favorably with other methods used to detect substances in the body. When enzymes react with appropriate substrates, a change in color occurs, which is used as a signal. However, the signal has to be associated with the presence of antibody or antigen, which is why the enzyme has to be linked to an appropriate antibody. I hope this presentation has given you a love of ELIZA. I would encourage you to take this class that shall remain unnamed. The professor is excellent, and we could always use more honey badgers.